3 days until the AP Calc AB exam. This is video 2, explaining every derivative rule on the exam. No proof, no theory, just the rules, examples, and what actually gets tested. So, first of all, we have the limit definition. You have to know this for the MCQ. We won't use this to calculate, but it will appear in disguise on the MCQ portion of the test. So you must recognize it. It comes in the form of f prime of x, which is a derivative of x, is equal to the limit, which I explained in the last video, as h approaches 0 of f of x plus h minus f of x divided by h. Now, if you see this form on the exam, it's asking for a derivative. So identify f of x and a, and that's how you solve the problem. Next is the most important rule for AP Calc AB, also known as the power rule. Basically, the derivative of, so d over dx of x to the power of n, this is equal to n times x to the power of n minus 1. This works for any real n, so fractions, negatives, decimals. Take this for example, d over dx of x to the power of 5. This is equal to 5x to the power of 4. Or d over dx of square root of x, which will equal to d over dx of x to the power of 1/2. So this equals to 1/2 times x times to the power of negative 1/2. And then the derivative of a constant is 0. And the derivative of c times a function f of x is equal to c times the derivative of f prime of x. So it's just c times f prime of x. And next, we go to a bit more complicated stuff. First, we have the product rule, which states that the derivative of the product of two functions, so f times g, is equal to f prime times g plus g prime times f. So is first d second plus second d first. Then is d over dx of the quotient of two functions, so f over g. Well, the mantra for this problem would be, first of all, it's f prime of g minus f times g prime over g squared. To memorize this, just remember low d high minus high d low over the square of what's below. Now for quotient rule, the minus sign goes in the numerator, not the denominator. So that's the most common mistake. And now we have the derivatives of trig functions. For example, d over dx of sine x equals to cosine x. d over dx of cosine x is equal to negative sine x. And then d over dx of tangent x is equal to secant square x. So these are the three main trig function derivatives you have to know. And then you have d over dx of the reciprocals of these three functions. So d over dx of cosecant x is equal to negative cosecant times cotangent of x. Negative cosecant times of x times cotangent of x. And then d over dx of secant x is equal to secant x tan x. And then d over dx of cotangent of x is equal to negative cosecant squared x. So the cofunctions, cosine, cotangent, and cosecant, they all carry a negative sign. So it helps to save time if you know that pattern. And then we have the exponential and log derivatives. So d over dx of e to the power of x is equal to e to the power of x. So just remember for e to the power of x, it just stays the same. However, this is different for a to the power of x. This will equal to a to the power of x times ln a. Notice that e to the power of x is just a special case because here ln e is equal to 1. Then it's very common for the derivative of ln x to appear. This is just equal to 1 over x. And then d over dx of log x, log base a of x, this equals to 1 over x ln a. And as for the inverse trig functions, there are two you must know. D over dx of arc sine x, this equals to 1 over square root of 1 minus x squared. Then you have d over dx of arc tan x, and then this will equal to 1 over 1 plus x squared. As for arc cosine, it's just going to be the negative of arc sine derivative. And these show up in both the MCQ and then the FRQ portions. The denominator form is what trips people up, so you must remember the denominator for arc sine and arc tangent as square root of 1 minus x squared and 1 plus x squared respectively. And then a preview of the chain rule. If you have an example here, for example, like d over dx of e to the power of 3x. In this case, do not just write e to the power of 3x. You have to first take the inside derivative. So if you think of this function as e to the power of x, but inside here, x is equal to 3x. So you have to first take the derivative of the inside function, which is 3x. So that's going to be 3. And then you times it by the derivative of the outside function. So it's 3 times e to the power of 3x. So also remember for the conceptual questions that differentiability implies continuity, but not vice versa. If f is differentiable at a, it must be continuous there. So corners, cusps, and vertical tangents are continuous but not differentiable. The FRQ loves asking you to justify this. So all of these are our derivative toolkit. And the next video will cover the chain rule, implicit differentiation, and inverse functions, the hardest unit and the most tested. Subscribe if you want to see more videos related to the AP curriculum, and see you there.